All right. Hey, everyone. So today we are talking our last two types of congruence. It's angle, side, angle, and angle, angle, side. So ASA and AAS. So that'll bring up our list to about 5 triangle congruence theorems that we're working with. So let's get started. The first one, angle, side, angle congruence. In order to have angle, side, angle, looking at this picture here first, we need to have 2 pairs of angles. So we've got 1, 2 pairs. And then we need something called the included side. So kind of like with side angle side, what we had there, a similar thing happens here. The side that we need has to be in between the 2 angles that we have. So in this case, one way that you can kind of determine if it's angle, side, angle is if you draw a line that connects the 2 angles that you have. That should be the side that you know is congruent to the same side in the other triangle. So included is another way of kind of saying in between. So when we ask what is meant by included, that's going to be between, because we want what's between the 2 angles. Another way that you can kind of think about it is, okay, if we give each of these angles and sides the letters A and S respectively, we have A for angle, S for side, A for angle. It does go ASA. So that's another way that you can tell. And remember, you do have to check both triangles and make sure that it works out in both of them, that we have angle, side, angle here as well. All right, so that's angle, side, angle. And then the other one that we have for us today is angle, angle, side. So angle, angle, side is going to look a little bit more like this, where we have a non-included side, although we still have that same thing where we have 2 angles going on. So we should have 1 pair of angles, 2 pairs of angles. There's our 2 angles. And then we need to have a side that's not included, so not in between. So in this case, we have these sides here. You could also use this other pair of sides, as long as it's not the one that's in between the 2 angles. So in this case, if we were to label everything, A for angle and S for side, you have to be a little bit careful here and not accidentally count things out of order, but we should get angle, angle, side if you go around the triangle like that. Angle, angle, side, angle, angle, side. So on this one, non-included just means the side that's not between. In this case, not between the angles. So now we're going to look at some questions that are fairly familiar to us, but now we have more options for our answer. So looking down at these examples, we're deciding yes or no if the triangles are congruent or not. And if we decide yes, then we have to choose from our reasons of SSS, SAS, ASA, AAS, and HL. So now we have 5 possible reasons why they could be congruent. And to kind of help ourselves narrow things down a little bit, there's really specific situations where you might use some of these, like HL, for example. You have to have right triangles. So you can't even consider HL unless you have right triangles. Or SSS, you don't even consider that unless you have all of the sides on both triangles. Or ASA and AAS, you need to have 2 pairs of angles. If you don't have 2 pairs of angles, you can't consider those. So it becomes fairly easy to narrow down our choices once we get used to looking for these things. So let's try the first one here. On this one, we might notice that we have 1 pair of angles, and they're not right angles. So that automatically gets rid of all 3 of these, HL, AAS, and ASA. Now we're just looking at these 2, either SSS or SAS, since we only have 1 pair of angles. And looking here, we've got 1 pair of sides, 2 pairs of sides, but not 3 pairs of sides. So this one, the only real candidate is SAS. So just to double check that it is indeed side, angle, side, what I would do is trace the two sides that I have. And if the angle that I have is in between the two sides like this, then we're good to go, and it is side, angle, side. So in this case, we would say our triangles are congruent by side, angle, side. And if you want to, you can also label side, angle, side, angle, side, just to double check and make sure. All right, let's try the next one. On this one, we might notice that we have two pairs of angles. So that should automatically make me start looking at these two, angle, angle, and angle, angle, side. So we have two angles and we have one pair of sides. And so if I draw a line connecting my two angles, you might notice that the side that I have information marked on is not that side. It's not in between the two angles. So in this case, our answer is yes, they are congruent, but it's angle, angle, side. Another way that you could figure this out or think about it is go, okay, that's an angle, that's an angle, that's a side, that's an angle, angle, side. And if you read them in order, AAS. Okay, so whatever way works best for you to think about it is how you should do it. In this case, it's angle, angle, side though. Okay, number 3 is a little bit different. On number 3, we might notice that we actually have 4 pieces of information given to us. And in all of these, you really only need 3 pieces of information. So the nice thing is when you have 4 pieces of information, you could use more than one of these congruence theorems. So in this case, let's see, do I have a side, side, side situation available? And the answer is no, I don't, because I'm missing this side here and this side here. So SSS isn't going to work, but I can see an SAS situation going on where we have these two sides and this angle included. These two sides and this included angle. We do have a side, angle, side situation here. So we can say yes, SAS is one reason that we could say that these are congruent, but why stop there? We also have angle, side, angle, because we have these two angles and this included side. These two angles and this included side. So ASA works. And actually, AAS also works on this one. You could go angle, angle, and then the not included side. Angle, angle, not included side. The only ones that don't work on this are SSS and HL, because this is not a right triangle, so I can't use HL. All right, so that one's a little bit different, but kind of fun to look at. The fourth one. Looking at this one, we've got one pair of angles. And we have 2 pairs of sides. So the only real candidate we should be looking at is SAS on this one. So to decide if it's actually SAS, I'm going to trace the sides that I have on both triangles. And we notice that on this one, it looks like SAS. We have side, angle, side. The angle is in between the 2 sides. But on this one, we have a problem. The angle right here is not in between my 2 sides. So this one is, there's actually not enough information to tell if they're congruent. So no, not enough info. Okay. For these next 3, I would encourage you, if you have these notes on your own, to pause the video for a second and see if you can figure out these 3. I will continue and talk about them, but give it a try. See if you can figure any of them out on your own. All right, so hopefully you paused the video and tried them on your own. If you didn't, that's okay. Here we go. Number 5. For this one, you should have gotten no, not enough info. And this one is tricky. It's kind of like this one on number 4, where you do have two sides, but the angle that you have is not between the two sides. So that's a problem. So this is that side angle situation, and there is no side angle postulate, unfortunately. So this one's not enough information. Number 6, you should have gotten that yes, they are congruent, and it's by HL, hypotenuse leg. We notice that these are right triangles, and the hypotenuse is the side that we know on both of them. And then we also have a shared side in the middle that is one of the legs. And so this one works with HL. And then the last one, we should notice that there's a shared side there in the middle that we can label. And so this one is, yes, they are congruent by SSS. So we have all 3 sides on both triangles labeled. Okay, so that's one style of question you might be asked to work with here. Another type is very similar to this. Decide whether you can use the given information to prove that triangle LMN is congruent to triangle PQR. And so they give you some information down here, and you have to decide if they're congruent or not, and if so, which congruence theorem. So notice the only real difference here is that there's not a picture drawn for you. And so in this case, if there is no picture, let's draw a picture. So it doesn't really matter what your triangles look like, as long as they are labeled LMN and PQR. Then we want to take this information down here and label in our picture. So we have to show that M is congruent to Q, and that N is congruent to R, and that NL, so this side, is congruent to RP, this side. Okay. And now we have the same kind of a situation that we had in these problems 1 through 7 up here, where we've got a picture, we've got some stuff that's labeled, and we have to decide, are the triangles congruent or not? And I'm inclined to say yes for this one, because we have 2 pairs of congruent angles. We have 1 pair of congruent sides, so automatically we should start thinking maybe it's going to be ASA or AAS, because those are the ones with 2 angles needed. And in this case, I'm going to say angle, angle, side. And if we look at this one, it's also AAS. The side is not between the 2 angles, so it is AAS. All right. This one over here is very similar. I'm going to do the same kind of thing. Draw 2 triangles, LMN, PRQ. On this one, though, we have triangle or angle L is congruent to angle R. And we have angle M congruent to angle Q. And then we have LM congruent to PQ. So that's everything we should have labeled on this one. Now, this one looks a lot like the last one that we had. There's just a little twist. So on this particular triangle here, the LMN triangle, we have something that looks a lot like angle, side, angle. The side is the included side for those angles. But on PQR, we've got angle, angle, side. The side is the non-included one. So if I would choose ASA for this one, but AAS for this one, that means that there is not enough information to tell if they're congruent. So we would say no, not enough information for that one. Okay. So those are a couple of types of problems that you'll see for this. The last kind of problem that we're going to look at together today is a proof. So if you have this packet, go ahead and flip it over to the next page. And we're going to actually start with the one that's in the middle. So I know they're both, it's a little confusing. They're both, the top one and the next one are labeled 11. We're going to start with the middle 11. Because this one's just a little bit simpler than the top 11, we will get to that one later. So for this one, I'm going to start with looking at our givens. We know that angle N is congruent to angle P. And we know that angle MQN, so this one, is congruent to angle QMP, which is this one. This proof, it's also going to be helpful to kind of look at what triangles I'm looking at, because there are a lot of actual, triangles within this picture. Which triangles am I trying to show are congruent? Well, in this case, it's going to be triangle QPM, so that's this one. And then also triangle MNQ, which is this one. So as I traced those, we should have noticed something that I traced over one side twice. This one here. That means we have a shared side. So that's something we can also mark in our drawing. Now, to kind of help with starting off going, okay, is this going to be SSS, SAS, ASA, or AAS, or HL? One thing I might do is, since this drawing is a little bit messy, I'm going to take one of the triangles out. I'm going to grab the red triangle MQP, and I'm going to keep all the things that I had labeled on it, but I'm going to have it sitting here by itself for a minute, because that's going to help me with my decision process here. So it's not SSS, because we don't have all the sides. It's not HL, because we don't have a right triangle. So that narrows that down. We do have two angles, so I'm inclined to start looking at these two, ASA versus AAS. So now I might label, okay, there's my angles, there's my side. In this case, it does go angle, angle, side, because the side is not between my two angles. So this is the one I'm going to use for my last step. So even before we start the proof, we can figure out that much, just using the skills that we learned earlier in this lesson. Okay, so back to our proof. This proof is going to have 4 steps. And we always start our proofs with the givens. So I'm going to put these two into my proof. We've got angle N is congruent to angle P, and angle MQN is congruent to angle QMP. Then we can go ahead and put in the last step. The thing we're trying to prove always goes as our last step. So we should have triangle QPM congruent to triangle MNQ. And then that was, for our last reason here, the AAS. Okay, so now there's just one step left in the triangle proof, and there's one thing that we labeled in our drawing that we have not yet talked about in our statements, and that is this shared side. So remember, the way that we acknowledge shared sides is to go MQ is congruent to MQ, since that's our shared side. And that was the reflexive property. Property of congruence, POC. And there we have it. There's a triangle proof using AAS. Hopefully this was helpful. We will continue on this topic tomorrow, so bring questions with you to class if you have questions. Have a great day.